and then I'll give you some task, and then you'll get going from there. Huh? All right. So let me show you the application screen to everybody, and I can share with you. Let me put this one behind, and let's go to this one. Definitely everybody can see it, right? Yes, we did this one, and if you cannot see, let me know. I think you should see it. So we did all of them we did it because just February, last Wednesday, I guess. We also did this, and we came up with, yes. All right. We did not do the hydrogen peroxide, H2O2. So that's a methane, ethylene, acetylene, and that's our H2O2, hydrogen peroxide. How do you do the hydrogen peroxide? Very similar. Oxygen is more electronegative, put in the middle. One hydrogen this side, you have two hydrogen, another hydrogen this side, right? And as you know, hydrogen has one electron, oxygen has one unpaired electron, two single electrons, right? On this side. And the rest of the two electrons, so you just put it like there, right? That's water, H2O. But when you do hydrogen peroxide, very similar, H, O, H, and H. Now, everybody okay with me? If I'm writing one line indicates one bond, two electrons. So we do not have to do those electrons, we don't have to show it if you do not want to. And then oxygen is always, you have to put this one. Oxygen, anywhere you see the oxygen, any compound, you just name it, you have to have these two pairs of unpaired electrons always there. They're used for some purposes for chemical reactions, but in terms of the structure, they're always like this. So that's our hydrogen peroxide versus H2O, right? You can also do the carbonic acid. Carbon is a lesser electron density, right? Electronegativity, you can say, carbon in the middle. And then you have a hydrogen, two hydrogen. So one hydrogen, let's see right here. You can put another hydrogen right there, right? You can write anywhere you want. And hydrogen has one electron like this. Carbon has one electron like this. So they'll make a bond. And we can just write the bond, in fact, without showing these two electrons. And now the oxygen. We can also have oxygen like this. And we have I'm sorry, you cannot do that way. You have to put it, let's cross this one. So basically you put H. H cannot be connected to the carbon in this case. It has to carbon to the oxygen, not the carbon. And the carbon, and then also you do the oxygen, and yes. All right, and then you have two more oxygen, one oxygen remaining, and that will be our, you have to make a double bond like this. So this is the Lewis-Dawes structure. Not exactly, because you have to put something else. Now you have two electrons, everything fine. As you can see, the hydrogen has two electrons, so helium configuration. Hydrogen has helium configuration, but oxygen is not. So you have to put these two dots like this. All right, always wherever you see the oxygen, you have to put the two pairs of unpaired electrons like this. So that's your carbonic acid. All right, so that's if you look at the carbon number, electron number, 2, 4, and 4, 8. 2, 4, 4, right? Double bond 4, because 2 electron, 4 electrons. So that's 8. And this is oxygen. There's 2, 4, and this 4, 8 electrons. Carbon, 2, 4, and 4, 8 electrons. So octet rule. They always follow the octet rule, right? Likewise, you can do this one. This is called formaldehyde, by the way. This is called formaldehyde. And you see the
I think.
Yes.
Because like she got like something like that, but I know it's like.
Say it louder, please.
Expensive.
Huh?
And the only reason she went was because she had like a gift certificate.
Someone's mic is on.
Mic is on. Okay, so formaldehyde. So formaldehyde is called CH2O. So CH2O formaldehyde, it has like this, it's a molecular compound. You have hydrogen 1, you have a hydrogen this side, and so one electron, carbon has one unpaired, and you can just put it like this and like this way. Now you can also make a one unpaired, another unpaired with oxygen. And oxygen has, remember, you have a two unpaired electrons like this way, and it has another additional electron like this. And therefore, and carbon also has the same thing. So you just make a double bond like this way. So this is our helium configuration. So as this one, and 448, and this 448 octet rule. So that's basically you do the Lewis dot structure. Now we can go some general rules. There are some general rules for the Lewis dot structure. We're doing it just because we already know the valence electrons and how many electrons the one can have, and following the octet rule. There are some rules for the Lewis dot structure, and those are called Lewis dot structures of molecular compound, and these are the one basically rules. But we already said it, and you'll see them again. But I want to make sure that these are the rules we applied, and I'll show you how why we applied. According to Lewis dot structure, Lewis is the name of the scientist, by the way, right? He's from University of Nebraska Chemistry Department, by the way, long time ago, 1940s. And then he basically draws those structures using those number of electrons in the valence shell, electrons in the outer shell, periodic table. So determine the number of valence shell electrons in the molecule first. So if you have given a molecule, you can derive the Lewis dot structure very easily. I'll give you some example. Decide on the arrangement of atoms in the molecule. Usually an element with a lesser electronegativity, usually in the middle, but you'll see some examples there, exceptions there too. Connect the atoms by single bonds. Single bond has two electrons. Show bonding electrons as a single line. Single line indicates two electrons and a single bond. So non-bonding electrons as a pair of Lewis dots. That's oxygen that you saw, right? Oxygen has always two pairs of electrons. In a single bond, atoms share one pair of electrons. In a double bond, they share two pairs of electrons. And triple bond, they share three pairs of electrons. This you already have seen it, but I'm going to give you these general rules. Now we'll do some, I'll show you, this already we have done it too. So water molecule, as you saw, I'm not going to write the dots again because this already rule applies. So you have line indicates two electrons, electron 4 and 2, 2, 4. That's a water molecule. And if you count, yes.
I'm sorry, I do have a question. I was waiting until you finished this slide. Can you go back one more?
I think I'm here. Is it right?
No, no, like go back to the examples. Yes.
Okay.
I was just waiting until you're done with that slide to ask the question, but okay, so like for example, the H2O one up there, where it has the two H's and then the oxygen in the middle. The one next to it, would that also be H2O?
This is H2O2.
Oh, okay, yeah, okay. My bad. I was confused.
No, I'm comparing the two together, side by side, huh? All right.
Yes, okay.
Okay. So now, since we have done the water, we know, so the total number of our electrons, valence electrons, oxygen has 6, right? Group 6. So 6, hydrogen 1, 8 electrons. So these are the number of electrons in the outer shell, all together in the molecule. And that's the structure. Likewise, ammonia, nitrogen has 5, hydrogen has 1 times 3, 8, and that's 8. And that's basically put it like this way. One bond, so 2, 4, 6, and those two pair of electrons, 8. Carbon has a 4, group 4a, and 4 hydrogen, 8 electrons, and altogether you have 2 electrons here, 2, 4, 6, and 8. Perfectly fine, right? So carbon shares the octet rule, hydrogen shares the helium rule. Likewise, HCl, hydrogen has 1, chlorine has 7, group 7, right? 7 plus 1, 8 electrons, total number of electrons. And you can just put the one bond indicates 2 electrons. Then you have, so hydrogen is satisfied with the helium configuration, and you have 2, 4, 6, and 8. The rest of them are dots. So that's basically why we did it, and we are showing it again. Here is the ethylene. Ethylene has 12 electrons, 2 from carbon, 2 times 4, 8, and 4 hydrogen. So 8 plus 4, 12 valence electron altogether. And you have to put them all together. And so what you can do, carbon in the middle first, as you do, and then the hydrogen, share the hydrogen with 4 hydrogen with 2 of them, 2 each carbon. And then you have a single bond, that's a sigma bond. Then you have to put a pi bond although it is not shown, but remember this is a pi bond, one pi bond, one sigma bond. So if you look at the carbon, 2, 4, 6, and 2, 4, and 8, 2, 4, and 4 plus 8, same carbon, 2, 4, and 4, 8. Likewise, you can do the acetylene. Acetylene also have a 2 hydrogen, 2 carbon bond, and 2 hydrogen, carbon-hydrogen bond. Each bond 2 electrons. So therefore, you already have one sigma bond, one sigma here, one sigma there, one sigma there. Then this carbon has 2 additional electrons, so as this carbon, and put those bonds, 2 pi bonds. So ethylene has 1 pi bond, acetylene has 2 pi bonds. Formaldehyde, we just did it few seconds ago. Carbon 4, hydrogen 2, 4 plus 2, 6 plus 6, 12 electrons altogether. Arrange them, carbon and hydrogen, 2 electrons, and another 2 electrons right here. Oxygen has 1 electrons, 1 additional electrons. Carbon has 1 additional electrons. We have 1, so it's a double bond. And the rest of the 2 electrons stays as it is. Carbonic acid, we did the same thing. Carbon 4, 3 oxygen, 4 times 6, 3 times 6, 18, plus 12, plus 2, 24 electrons. And then you can do the same way that we did the arrangement previously, right? So what do you do? Carbon in the middle, double bond, and a single bond, and oxygen, hydrogen, oxygen, hydrogen. Hydrogen always in the terminal, because it has only 2 electrons, and one bond is 2 electrons. That can, on maximum, it can have 2 electrons, helium configuration. So carbon in the middle, oxygen outside, and hydrogen way to the extreme end of the molecule. So that's our carbonic acid. So this is the following the Lewis dot structure. All those rules 1, 2, 3, 4, 5. Okay. Now I'm going to give you some, and you do it. And
Hey,
this is,
I'm
yeah.
sorry. Okay, so
Yeah.
yes, so carbon, okay. If carbon, hydrogen, and oxygen are in a group like that, is carbon always going to be in the middle?
That is correct. That is correct.
Okay.
Lower electron density. It will be correct. You're right. You're absolutely right. So that will be in the middle always. All right. So let's do the Lewis dot structure of this molecule. Let's see who can do it. I'm not going to do all of them. I'm going to give you some, and you do the rest. So nitrogen dioxide can do it. Let's see. Do it, and someone tell me how you do it.
Yes. I'm just gonna try it.
Yeah. Please do so.
You're gonna put N in the middle, and then
So first, give me some number. What are the total number of V's, valence electrons? Total number of V's.
the I do not know that.
No, you should. No, you know, total number of V's equal nitrogen, which group?
Nitrogen. Hold on.
Group 5.
Where's it at?
Yes. Yes.
I believe it's in group 15.
5. Well, group 5A. Group 5A. So
Oh, Jesus.
Yeah. So it's group 5A. Look at the periodic table. You should have it, huh? Periodic table. Keep the handy always. So group 5A, nitrogen has 5 electrons. How about oxygen? How many electrons are outer cell? B. How many B's? Yeah.
Yeah, no.
Look at the group number. Is
it 17? Because oxygen has 6, so 6 times 2 is 12, plus 5 is 17.
Yeah, of course. That is right. That is right. I just told you 5 total. So total number of V's equal 5 plus 2 times 6 is 17. Now tell me the arrangement. So you have a nitrogen. Yes. Nitrogen in the middle. Oxygen. Keep going. Someone is telling me. Keep going. Come on. Come on. Now what will I do?
It's going to be a double bond.
How many electrons are used? Only 2 to 4, and you have till 13 of them to go. So that means you have a nitrogen. Remember, nitrogen is a lone pair. Always give that lone pair. Nitrogen stays. Oxygen has a lone pair always. 2 bonded pairs always. Anywhere you see the oxygen, you do like this. Now tell me how many electrons are used already. So 2, 4, 6 here. 2, 2, 4, and 6, right? And then you have a 2, 4, and 6. So basically 6, 6, 12, 6, right? 6, 6, 12 plus 2. So 14 of them use 3 electrons still remaining. So what will you do next? So you take 1 electron. Nitrogen has, remember, 5 electrons in outer shell. So you can use nitrogen, 1 electron from there, 1 electron from there, and make a double bond right there. Now this oxygen has 8 electrons. 4 plus 4, 8. This nitrogen, 4, 6, and 8. How about this oxygen? What will do to this one? How many electrons you used? How many electrons left? How many electrons you used and how many electrons left? Yes? Come on, tell me. We use 2, 4, 4, 8, 10, 12, and 4, 16. We have 1 electrons remaining. Where will you put it? Where will you put it? You put to the oxygen. So oxygen stays like this. So that's the Lewis dot structure of nitrogen dioxide. Nitrogen dioxide. Now in this case, this oxygen is not fulfilling the octet rule. As you can see, 2, 4, 6, 7, because we do not have additional electrons. One oxygen is 8 octet rule. Nitrogen is octet rule, but this oxygen is not. This oxygen is not. All right. So there are some, and that's what the Lewis dot structure is all about. Not all cases it follows the octet rule. There are some additional electrons will be remaining, and that you have to draw it as it is. Now, can you draw the Lewis dot structure of ethane? CH3, CH3. Who can tell me the structure? I'm going to write it down. I'm not going to do all of them. You will do the methane, methanol. Yes. Who can do the structure of the ethane? CH3, CH3, ethane. Can someone tell me?
Okay, so I just wanted to ask about the first part of it. Would it be C, and then like, I guess it's not called an equal sign, but you know what I mean? Like draw another C and then the 2 lines between them.
So C,
yeah, like
yeah, okay, that's fine. And then you have 3 hydrogen, right? 1 hydrogen here, bond, 1 hydrogen here.
Yes,
bond.
and then it would be the same on the other side, correct?
Yeah, absolutely. 1, 2, and 3.
And then also, I'm just confused on the dots part. That's all.
No, this is it. That's it. Which part? Which part you are confused? Tell me.
Oh, about the dots that you put around the element?
Right. And now in this case, you don't have to because you used all of them. So ethane, number of electrons, total number of valence electrons is 6 plus 4 plus 4, 8, and 6, 14. And you already used 14. 2, 4, 6, 8, 10, 12, 14. They're all used up. So there is nothing, no electrons left, therefore no dot remaining. That's right. That's right. Now who can do the methanol for me? CH3OH. And you will do the someone ethanol is your practice test. You will do it. I'll do the ethanol for you. Methanol. What's the methanol? Who can do the methanol for me? Yes? Yes? Who can do the methanol? So total number of V, what's the V's? Total number of V is equal. Carbon is 4, hydrogen is 3. 4 plus 3, 7. Oxygen is 6. 13, 14. All right. Let's do that 14. Arrange it. So you have a C, oxygen, hydrogen, 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 and hydrogen. bond, 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 bond. Tell me how many electrons are used already. You have 14 altogether. How many of them are used?
10.
10.
10. So you have 4 remaining. 1 and 4.
I have a question.
Yeah.
Okay, so if your total number of electrons is an even number, you're not going to have a pair, or I'm sorry, you're not going to have an element that doesn't satisfy the octet rule, correct? Because
Some of them don't. For example, nitrogen, right here, this oxygen is not. That is
So-
correct.
nitrogen dioxide had an oxygen that didn't satisfy the octet rule because the total number of electrons was 17, and that's an odd number, right?
That's correct. If it is out,
Okay.
it will end up with that way. Very good. Yeah, that's more likely. That's right. Sorry. Ethanol, you do it. I'm not going to do it. Now, acetaldehyde. Who can do the acetaldehyde for me? Acetaldehyde. CH3CHO. Who can do it for me? Oops, sorry. Acetaldehyde. CH3CHO. We're doing this one. You'll do the rest. CH3CHO. Yes? So how many electrons are there again? Once again, carbon is 4, 3, 7. 7 plus 4, 11, 12, and 6, 18. So total V is 18. Now arrange them in 18. So you have a carbon, carbon, oxygen, carbon, carbon, oxygen. Hydrogen cannot be in between. Remember, hydrogen is only 1 electron, right? So therefore, this carbon has 3 hydrogen, H, H, and H, right? And this oxygen has 1 electron, 1 hydrogen, and H, right there. So 1, 2, and 3, and carbon-carbon bond, and carbon-oxygen bond. Now, see how many electrons used and how many remaining. How many electrons used?
12.
2, 4, 6, 8, 10, 12, and still have a 10, 12, right? So still have a 6 electrons. That we maybe it's right. It should be 16 then. I think it's 16. So 4 electrons will be remaining. No. Yeah. That is right. Okay. All right. So now you cannot do this one. Yes, yeah, no. 18. You're right. 18 electrons remaining. So you cannot do this arrangement. So you have to think about something else. Because now if you put those 2 electrons like this, you can put it like this. Now carbon is not satisfied. Oxygen is octet rule. Hydrogen is fine. Hydrogens are fine. This carbon is fine, but this carbon is not. And you still have a 4 electrons remaining. So now what will you do? So that means this arrangement is not right. So what you will do again? Let's do it again. H, C, H. All right. H, C, and H right here. Let's put it like this way. H right there. And you have oxygen right there. So this carbon has octet rule. This carbon is not yet, but you can make a double bond because you have 2 electrons, so you can do it there. So now this carbon has octet rule, and rest of the 4 electrons will be like this. So this is not the one. This arrangement did not work. And this is the arrangement will work. So you have to try it like this, right? How the electrons put it in there. First thing first, you have to calculate the valence electrons. Carbon has 4, group 4, 2 carbon, 4 times 2, 8, 6, so 4 times 2, 6, and then 4 hydrogen, right? So 8 plus 6, 14 plus 6, 14 plus 6, 18 electrons. Now carbon has 2 times 6, 2 times 4, well, that's a carbon, and that is your 8 electrons. 8 plus 4 hydrogen, so plus 4, 12, and 12 plus oxygen has 6, plus 6. So you have basically 18 electrons, and you have to put the 8 electrons like this way. All right. Now, who can do the lowest structure of this acid, acetic acid? CH3COOH. Can someone do it more for me? And then I'll give you another one. You also do that at home. COOH, and that is our formic acid. This is a formic acid. So let's do the acetic acid first. Who can do the acetic acid for me? Do the acetic acid. And then try at home formic acid. Formic acid. So at home, you do the ethanol, you do that acetone, CH3CO, CH3, dimethyl ether, you do that, and also do that formic acid. And let's do the acetic acid. Can someone do the acetic acid for me? Do the acetic acid. Yes? Do it and let me know. Acetic acid. What's the Lewis dot structure of acetic acid? Yes? Hello? Can someone tell me? So total, what's the total number of V?
Is it?
Let's get the V first. Total number of V. Tell me. TV. What's the total number of V?
Is it 27?
Let's see. So carbon has 4, right? 4 plus 4, 8. You're right. 4 plus 4, 8. 8 plus 4 hydrogen, 12. And 12 plus 6 plus 6, 12. It is 24, right? 24. Can you count it for me again? Can you count it for me? Huh? Huh?
I had got 24 when I counted it.
All right. So it's 24. Please count it again. I think someone told me 27. Please come in. Can you? So carbon is 4 plus 4, 2 carbons plus 4 hydrogen, so 12. And each oxygen has 6. Group 6, 6 times 2, 12. So 12 plus 12, 24. Yeah. Please check it. Huh? Now, give me the arrangement. What shall I do? Carbon. Yes. Carbon. Oxygen. And H. And this carbon is already occupied with 3 hydrogen. So you have a H, one H, another H, right? Bond, bond, bond. And we also have another oxygen. Let's put the oxygen right here. And a bond. How many electrons used up? And how many? And anywhere you see the oxygen, you must put this dot, as we told you earlier. Always. And you can put it here also. Always these lone pairs are always staying like this way. Now, how many of them are used up and how many of them are remaining? You have a 24 total. How many of them are used up?
We used 22.
Yeah, so 2 more remaining, right? What should we do?
Make
One from, yeah, yes, 8.
make a double bond between carbon
Sure.
and oxygen.
Right here. Yes, we did it. Yeah, you're absolutely right. So make a double bond, C double bond O. And that is correct. Now they are all fulfilled. So that's how you do the Lewis dot structure, and you do the rest. I already give you quite a few, and you do the rest, and I'll ask you on Wednesday. Okay? Now we'll go to the next one.
Professor,
I have a question.
Yes.
which ones do we have to do at home?
You have to do ethanol, CH3CH2H. You have to do the acetone, CH3CO, CH3, dimethyl ether, CH3O, CH3, and formic acid, HCOOH, HCOOH. All right?
Professor, I have a question. So you know how there's the double bond? Could that double bond go between the other carbon and oxygen? Does it matter? Like,
It cannot, because remember the CH3, so this carbon is occupied with the 3 hydrogen. It's already there. So this arrangement means that it is a 3 hydrogen attached to this carbon. And carbon, once you attach the carbon 3 hydrogen, you have a 2, 4, 6. 6 electrons are already there. And carbon cannot have oxygen. I mean, it cannot put oxygen right there. Because if you do, for example, if you do like this, something like that, carbon has too many bonds, so you cannot do that. So you have to just cross it.
But what
Yeah.
about the other one, the other like carbon and oxygen bond right there?
So the carbon,
Yeah, that one.
so this carbon, if you put it like this way, this is double bond, and then you cannot, carbon has too many now, right? Especially with oxygen has too many. You can have a carbon has 2, 4, 6, 8, 10. You cannot
What
have
if we
that.
take away the one double bond though? Like, could that double bond go between any part of like the carbon?
Yeah. This oxygen, if you put this double bond, then you have to take this one away, and that single bond away, and then put it right here. Yeah, you can do that.
Oh,
Yeah. Yeah, it doesn't matter. The arrangement doesn't matter, but as long as carbon has a double bond oxygen and OH. OH. Yes.
I have a question. You might have just answered it, but so like for that one, how do you know that the oxygen is like below the carbon? Like how do you know that like why doesn't the oxygen bond to itself?
Oxygen, it doesn't have to be below. You can put it on the top. Either way, it doesn't matter. It's a three-dimensional, right?
Yeah, but like why isn't it linear? Like why do you have to put it like on the top or bottom? Like why can't it be like CCOOH?
So let's say, let me write down here. So say COH. That's what you said, right?
Well, there's another O, so it's CCOOH.
Oh, I mean CO, something like that. That's what you want to say? Or OOH, O and O, right?
Yeah.
That's it. Yeah, let's do it. Let's do it. We'll do it. I'm using this space if you do not mind. So let's say C O and H. Is it right? Yes or no?
Yeah.
That's it. And then let's put 3 hydrogen here, because that is already said. 3 hydrogen there, 3 hydrogen there. 1, 2, 3. Very good. So this carbon is fine, right? 2, 4, 6, and 8. This carbon is fine.
Right.
Now, yep. Now, whenever you have oxygen, then you have to put these dots. Put those dots, dot, and dot. Now, see how many electrons are used up. Tell me. You count it for me.
22.
22. So you have 2 more remaining, right?
What?
You have 2 more remaining. Because 24
Right.
is a total.
Right.
So where do you want to put it?
Why wouldn't you give carbon, like the second carbon, its other 2?
If you gave other 2 like this, like this, that's what you said, right?
Right.
Now how many carbon? This carbon has how many electrons?
Oh, it has 6. That wouldn't work. So, okay.
It's not 8 yet, right? It's not
Okay.
Yeah. So that's fine. That's well done. That's okay. So that's why basically you have to put the oxygen in the separate, not together. Is it okay? All right.
So
All right.
for some
Yeah.
of these questions, is it almost like trial and error? Like you have to
Usually some cases it takes a little try. Yes, it's a trial and error. Some cases, because you have to see that some structure may not work. So then you have to modify it, and you have to follow certain rule. Yeah, it is a trial and error. Yes, it's a trial and error. Yes, it does. It does to some extent. Okay. If it is a complex molecule, it does. If it's a simple molecule, it's fine. You can do it just like looking at that.
So
All
are
right.
we gonna go over our homework questions on Wednesday to make sure we did them right?
Yeah, of course I'll check it with you. Yeah, you can check with me, or you can check with my officer too anytime. Yes, please do so. All right, let's go to the next one. So now let's do this. Who can do the sulfur dioxide for me? Let's at least try this one. Whatever time remaining. So sulfur has how many electrons? 6. Oxygen has 6 times 2, 18 together. So 18 total electrons, 18 total number of electrons. So how are we going to do it? Sulfur, oxygen, and oxygen. Let's do like this way. Bond, dot, and dot. Sulfur also is the same thing. Dot. How many electrons are remaining? How many used? How many remaining?
12.
Yeah. Yes.
And then
So you have 18. So 4, 2, right? 2, 4, 6, 2, 4, 6, and 2. So these two already counted, and so 6, 12, and 12 plus 4, 16. So what do we do? You have two more electrons remaining, right? What do we do? One goes there, one goes there. I think 4 electrons remaining. I'm sorry, counted there. So you have to make a double bond here. So oxygen, oxygen, sulfur, oxygen, double bond, sulfur, oxygen, double bond. So basically, you get this one, right? So now, and in this case, so these electrons basically used up. So you just erase this one. So you have a, now sulfur has how many electrons in outer shell? This sulfur has how many electrons in outer shell? You have a 2, 4, 4, 8. This oxygen is octet rule, 2, 4, 4, 8. And this sulfur also has a 4 plus 4 plus 2. So how come sulfur has more? What's going on with the sulfur? Look at this one, this sulfur even, sulfur trioxide. 1 oxygen right there, 1 oxygen right there, 1 oxygen right there.
Did you
Yeah.
answer why sulfur had 10, or are you doing this next example to kind of show it?
Next example to show it again, yeah. Now, so this sulfur has a 10. Now, how about this sulfur trioxide? What will you do this one? So look at what is happening. This oxygen has a 4 plus 4, 8. 4 plus 4, 8. This oxygen is fine. 4 plus 4, 8. How about the sulfur? Sulfur has how many electrons here? You see, one can say this sulfur, you can say these electrons are also used up. You can say 4 plus 4, 8. So maybe we can also cross this one. So this sulfur, you can do it like this way. Because you have 18 electrons total. So 4 plus 4, 8. 8 plus 8. Right? So you have a 4 plus 4, 8. And this 8, 16. You have to give 2 electrons, sorry. Yeah. And these 2 electrons. So sulfur has 10. 10 electrons, sulfur has 10, not a 8. And this sulfur has how many electrons? This sulfur has how many electrons?
12.
Yeah, oh my goodness. It's 12 electrons. So what's going on? What will we do? So sulfur has 10 electrons, usually instead of 8. This sulfur has 12 electrons. Let's do this one, pH3. P, H, H, and H. And 2 dots, just like nitrogen. So 2, 4, 6, and 8. So phosphorus is happy. Hydrogens are happy. So that's fine. How about P2O5? P, O, P, double bond O, double bond O, and you have a double bond O, and that's a P2O5. So now the phosphorus has how many electrons out of how many electrons phosphorus has? You can also have it like this. So phosphorus has how many electrons? Yes? This phosphorus has how many electrons?
10.
Yeah? 10. Right? 4, 4, 8, 10. That's right, 10 electrons. How about this phosphorus? Also has 10 electrons.
It's 1150.
Huh? Say it again.
It's 1150.
Excuse me, I didn't hear you. Say it again.
It's 1150. Class is over.
Oh, my time is up. Okay, all right. So remember, the phosphorus, sulfur, phosphorus, and also chlorine, they can have more than 8 electrons. So what's going on? We'll talk about Wednesday. Just I'm going to give you the A, and I'll put this on this slide too, so you can work on it and see draw the Lewis dot structure of phosphorus, phosphoric acid, perchloric acid, and see what's going on. Why do they have more than 8 electrons? So that's explanation will give you on Wednesday. All right, very good. I'll see you Wednesday then, and definitely do